Hi there and welcome to our lecture on the periodic table. This is Atoms 4 of Unit 3. Our key ideas: why do elements within a group of the periodic table have similar chemical properties? And what happens to an atom that gains or loses electrons? And what are the three main categories of elements? Our first thing is to look at the role of electrons. So why do elements within a group of the periodic table have similar chemical properties? And the result is of electron arrangement. So the way the elements are arranged on the periodic table is based on protons or atomic number, which with neutral atoms also happens to be the number of electrons that we have. So our next note here, valence electrons account for these similar properties. So an element's location in the periodic table is related to the electron arrangement. So for example, on the very left side of the periodic table, you've got lithium and sodium that are just below hydrogen in group 1. Each one of these have one valence electron. And basically, what a valence electron is just the outermost electrons. So with lithium here, we've got two orbitals, or two rings outside the nucleus. The nucleus is a little black dot in the middle. And we've got two electrons, well, lithium for one thing, atomic number 3, it also has 3 electrons. 2 of those go in this inner ring, and then the other one goes in this outer ring. And then with sodium, the first ring can only hold 2, the second can hold 8, and the third can hold more. But we only have one more electron. So sodium had 11 protons, or 11 electrons, because it's neutral, it has the same number. So we have 11 minus 2, leaves us 9 left, and then we have 8 that'll fit in this ring. So 9 minus 8 gives us 1 left. So we have this one electron in this outer ring, or this outer shell. And that is the valence electron. We only have one electron in that outer ring, outer shell. It's referred to as the valence electron. So looking at oxygen here, oxygen has 8, 2, 4, 6, 7, 8 electrons. So 2 will fit in this first shell. The remaining 6 go out here. They typically occur in pairs, that's why these two are shown together. And then we've got 2 lone electrons that are by themselves, but this total shell number, this total number of electrons in this outer shell is 6, and that's how many valence electron oxygen has. In a later unit, we'll talk about how these 2 outer electrons will bond with other elements. With oxygen here, oxygen tends to gain 2 electrons because it's easier than losing these 6 when it bonds. So it'll actually get a negative charge because it'll have 2 more electrons than it has protons. So we'll talk about that later. And that's referred to as an ionic form of oxygen. With sodium here, again we have 11 electrons. 2 on the first shell, 8 on the next one. We have 1 left over, so it's on this outer shell. And what happens here, it's got 1 valence electron, and it wants to have at least 8 in this shell. It's going to find it easier to lose this 1 electron than gain 7 more to fill that shell. So sodium will actually lose an electron, have 1 less electron than it has protons, causing sodium to end up with a positive charge. And then finally we have a neon example here. Neon has 10 electrons, 2 in the first shell, 8 in the outer shell, so it has 8 valence electrons. It wants to have 8 valence electrons, so what happens is neon tends to be unreactive because it's got a stable outer shell. It's happy. It likes to have 8. So what happens when the atoms gain or lose electrons? If an atom gains or loses electrons, it no longer has an equal number of electrons and protons, because the charges do not cancel completely, the atom will have a net electric charge. It is then referred to as an ion. Group 1 elements, so that first, at the very left side of the periodic table, will form positive ions because it has a single valence electron that's easily removed. Group 17, so the second to last on the right side, will gain an electron, so they become negatively charged. They form negative ions, and they do have names. Positive ions are cations, negative ions are anions. So getting a visual here, we've got a lithium, which is found in that first group. Lithium has one valence electron out here. It's going to be easier to lose that one, the gain 7. And when it does that, it loses the electron. It now has a stable outer shell. We've got 2 electrons. We've got 3 positively charged protons. So the difference between this 3 positive charged proton and this negative 2 electron. So we've got 3 protons at a positive charge. We've got 2 electrons at a negative charge. So the difference between that is a positive 1 charge. Here we've got a fluorine atom. Fluorine has 7 valence electrons, so it's going to be easier to gain 1 electron than lose 7. What we have then is 9 positively charged protons, and we have gained electrons, so we have 8, 9, 10 electrons now. So the difference here is a negative 1 charge. So there is a trend that occurs across the periodic table as we move across as far as how many valence electrons each of these groups have. So starting with hydrogen here, we've got 1 valence electron. Moving over to beryllium, we've got 2 valence electrons. These guys in the middle, again, their valence electrons will vary. So we're probably not really going to worry about these guys in the middle. So 1, 2, going over to boron here, we're just going to keep counting. 3 valence electrons, carbon has 4, nitrogen has 5, oxygen has 6, fluorine has 7, and with the exception of helium, starting with neon, has 8. And then helium has 2. But starting with neon, going down, there's 8 valence electrons. And these trends apply to the elements that are underneath that number. So they will go down from there. So the elements that fall underneath will have that same number of valence electrons in general. There's some that vary over here on the right side of the periodic table, but in general this is the trend that occurs with valence electrons. We've got another note on how elements are classified. This is kind of a continuation from our last lecture. We've got 3 main categories of elements. They're either going to fall into the category metal, non-metal, or semiconductor, or metalloid. So elements in each of these categories do have some similar properties. So metals, an element that is shiny and conducts heat and electricity well, is referred to as a metal. A non-metal is an element that conducts heat and electricity poorly. And a semiconductor or metalloid is an element or compound that kind of does both. It conducts electrical current better than an insulator does, but not as well as a conductor. So we've got some examples of each of those on this next slide. So metals, good conductors of electricity, good conductors of heat. They're ductile, which means they're easily drawn into wires, malleable, so they can be shaped or formed, and most are shiny. So we've got a couple examples: copper, lead. Non-metals, they're not good conductors of electricity, they're not good conductors of heat, they're not malleable, they're not shiny. Basically, they're opposite of metal. Carbon, sulfur, these are examples, elemental examples. Semiconductors or metalloids share properties with metals and non-metals. They can conduct electricity under certain conditions. You can find them in chips and computers. Silicon is what they use for those. So, thanks for listening.